Okay, so let's move to the other side of the planet and talk about the other rover, Curiosity, which has been there since August of 2012. So we're on day 1766 today. And this is the goal of Curiosity. It landed a number of kilometers from this 5-kilometer high mountain called Mount Sharp, which is layered sedimentary rocks. And so the intent is to slowly sample many of these layers and drive up through a gully to about in here, if they can make it that far. And so they've been doing that. They have lots of good instruments on board to look at the geochemistry of the rocks. They can drill into the rocks, collect samples. They can zap them with a laser, vaporize them, see what the rock is made of by looking at the plasma that comes off of the laser hits with spectrometers. And so we're continuing that. So here's the view from overhead. Here's where they landed, and Mount Sharp is down here. The unfortunate situation was this dark stuff. It's called the Bagnold sand dunes, and that's a very thick deposit of basaltic sand. And so they didn't feel like safely they could cross the sand without potentially getting stuck in it. And so they've spent these 5-ish years now, or 4 years, skirting the sand dunes and doing all sorts of science on the way. So here's where they are right now. And what the near-term target is this ridge called Vera Rubin Ridge. And it's based on observations from orbit. This is very rich in hematite and iron sulfate mineral, which at the opportunity site, that was associated with minerals that form in the presence of liquid water. And I should have brought one of these pictures, but if this doesn't ring a bell, look it up on Google. Look for Martian blueberries. And there's these little spherical particles about the size of buckshot or BBs that are formed out of the hematite. And very conclusively, the hematite at opportunity was caused by liquid water. And so that's what they're looking for here. So the plan is to get up on top of this ridge and examine the hematite and how it's layered and whatnot, and then drive down the backside of it. On the backside, there's an abundance of clay minerals, which also indicate the presence of liquid water. And so by looking at the chemistry of these rocks, they should be able to untangle if the water that caused those two different types of materials had a different composition, if you will, different minerals dissolved in it. What was the pH of it? How acidic or basic was it? And so that's a major part of this mission is going to happen just in this, it's a 1.5 kilometers or so of driving. And so I want to show you a picture looking toward this area from about 1 kilometer away. And so what I'm about to show you was taken from here, looking down in this direction. I guess this is just a closer up view so you can really see that ridge. Okay, so here's from that vantage point. Here's Mount Sharp. Here's the sand dunes that they've now crossed. And this sort of dark stripe right here, that's the Vera Rubin Ridge. So they're now parked about right here. So that's X marks the spot, or plus marks the spot of where they're at right now. And so they're examining this this face of the ridge, or the scarp that's on the bottom of it. That's about 5 meters or so high, this lip that they're driving along the bottom of. So, 18 feet or so. And so here's the view from up close. And so here's the ridge. So they want to get up on top of this, but you can see that it certainly looks very different than the material that's below it, and the material that they've been driving across for quite a while. And this is just a monochrome version. Obviously lots of layering in it, which again makes geologists very excited to see any kind of layering, because that means whatever the processes were that laid this down, they were periodic and happened over some extended amount of time. And so what they've been doing is just slowly creeping along this to characterize this area. And from orbit, they think they know where they want to climb up on this, but obviously they're not going to be able to climb steep faces like that. But there are some areas where it's a more gentle slope. And speaking of climbing, and we've talked about this a number of times, the wheels, or tires, if you will, on Curiosity have been, for the last couple of years now, have been showing a fair amount of wear. These are carved out of a solid block of aluminum, and so they're not inflatable, but you can see that there's some holes that have been punched through the aluminum. There's some broken treads from the tire, and they've been working on sort of making sure that they don't end up with a broken wheel just as they find something really exciting that they want to drive to. And so they've been doing everything they can to make sure that they don't drive over sharp rocks, that they don't get in areas where they're going to cause an excessive amount of damage. And so in the last couple of months, they've rolled out a new software package for the rover itself. They've determined, so there's 3 wheels on each side, and it turns out that things like this, they think happen when, like that middle wheel, so this is the middle wheel, there's another one over here that we're not seeing. When it comes up on a rock, the front wheel and the rear wheel, they keep driving, and they don't realize that one of the wheels is actually getting banged badly against this rock, or trying to climb over the rock. And so they actually think that if you're driving forward, the front wheel is sort of pulling this middle wheel along, the back wheel is pushing it along, and if they could figure out how to detect when one of the wheels is in trouble, if you will, or coming up on an obstacle, they could back off on the other wheels and make it more gentle for the problem wheel to actually get over the obstacle. And so they've introduced that, and it actually seems to be working. They think they've reduced the stress on the front wheels by about 20%, on the rear wheels by about 12% or so, and that's a good result. And so this is just a video of a test in California of their testbed rover. And the thing to notice, so here's the middle wheel, and I'll back that up, but watch how fast the front wheel is spinning. Once this one hits this little obstacle, this one slows down. So right there, it sort of slows down, and then that's what the effect is, that they'll be a little more gentle. So, just wanted to end here with a couple of pretty pictures. This is a sunset taken early this month. Actually, I'm sorry, it was on the 14th of July. It was right before they put the spacecraft to bed for conjunction. And so if you haven't seen this before, the way that the dust in the Martian atmosphere scatters sunlight, you get blue sunsets instead of red sunsets. So this is part of Mount Sharp. Here's a hillside that's very near the rover. And anyway, that's what the sunset looks like in Gale Crater. And this was the most recent image returned, just a couple days before the spacecraft was put to bed for conjunction. And so there's that ridge. This is a fisheye camera view of what's ahead of the rover. So that's where they'll be heading when they wake back up. And so here's the recap for Curiosity. Again, it's day 1766, driven about 17 kilometers. And this guy has 17 camera systems on board, so it's a very productive shutterbug. And these are great to look at. If you haven't done it, just Google Curiosity mission raw images, and it'll take you to the website. You can look at all of the different camera systems, and they upload the data every day that there are new data received. So it's sort of fun to look over the shoulder of the rover as it's tooling across Mars. And then this was it was just sort of a fun story. In May, with the Hubble telescope, they targeted Mars at a time when the Martian moon Phobos should be visible. And this is, they got multiple exposures of it, and so that little dot is Phobos. And that's only, it's something like 20 kilometers in the long dimension. It sort of looks like a potato. And anyway, that's just a neat image. In ground-based telescopes, Phobos and Deimos, the two Martian moons, are extremely difficult to see. Mars is a very bright object. Those two moons are very small and very dark. They're like charcoal briquettes. And to be able to actually sort it out is quite a feat. And there's just a nice animation or splicing together of the time lapse that they took of Phobos moving around Mars.